Okay, so we know how important science is, but maybe we should learn more detailed information through public outreach, such as science exhibitions like this one that happened in DCU on seismology. Seismology is essentially the study of earthquakes and how they happen in the interior of the Earth. Here is a map of the major tectonic plates around the world. You can see that Ireland is on the Eurasian plate. The red lines show where these plates meet, and these are called fault lines. The majority of earthquakes happen here due to the tectonic movement. Here you can see how the plates are like a jigsaw puzzle sitting on top of the Earth's mantle. The cracks are the fault lines where these earthquakes occur. Here is a picture of the San Andreas fault line, which runs through California. It is well known for the amount of earthquakes that occur here each year. These are caused by the movement of the tectonic plates until they slip and rocks break. This can be seen with aeroboard as two pieces rub against each other. The stress build-up can be demonstrated by bending a stick. Eventually the stress becomes too much and the stick breaks, much like in an earthquake. When the rocks break, shock waves or seismic waves travel like ripples from the focus or the start of the earthquake. Some waves travel through the body of the Earth and some along the surface. These travel at different speeds. When these reach a seismometer, a signal is picked up on the computer, and the arrival times of these waves are used to calculate the distance from the earthquake. This will now be demonstrated by a role-playing activity, where each person has an individual role within the earthquake. The people on the edges are the tectonic plates, and they move in opposite directions until they slip. The P wave gets to the seismometer the fastest, followed by the S wave. The surface wave causes the damage and eventually gets to the seismometer. The person sitting at the computer is a seismologist. This is a scientist who studies earthquakes. The seismometer picks up on the vibrations caused by this jumping. This creates a mimic earthquake, which can be seen here. Each spike was caused by the jumping. Here is a real earthquake seismogram, showing the arrivals of each seismic wave. This is a seismogram of an earthquake which was recorded on the DCU seismometer. Seismic wave travel refers to the ways in which these waves can move inside the Earth. Every time the wave meets a boundary, it will move in a different way. Here you can see the main boundaries inside the Earth. At these, waves can refract and reflect. Refraction is where the wave passes into the next layer but is bent slightly, like a straw in water. Reflection is when the wave bounces back at a surface, much like a mirror or water reflects light waves. This can be demonstrated using lasers and prisms. The result can be seen here. This can be done in schools to demonstrate how seismic waves travel using light waves. This can be really fun to do as it allows us to see the different ways in which the waves can travel inside the Earth.